Hey team, I'm Maddie. Welcome to Science Side Up. And today we are going to talk about distant starlight. We're going to review a video from a young Earth creationist astronomer, astrophysicist, Jason Lisle, on distant starlight and why he thinks that's not a problem for young Earth creationism. Um, this is kind of a follow-up to the video that y'all should have seen last week. I'm pre-recording a bunch of stuff because I'm very pregnant. Um, now officially 9 months pregnant. So that's, wait, right? No, I think it was still 8 months. Okay, it's a lot of months, and I'm very big. Still recording from inside, from the fully air-conditioned space, because we're still in a heat wave out here in Oklahoma. Today's high is 110 degrees Fahrenheit, which is 43 Celsius. So to everybody who is trapped in the heat, like me, especially like people out in the UK, other parts of Europe that don't have the infrastructure for this, like listen, it gets to be 110 out here in Oklahoma, like usually every year, but it's usually like for a couple days in August, and that's it, right? Like these highs in July are like setting records, and I'm not a fan. But luckily, we have infrastructure better prepared to deal with that. So I am, as comfortable as I can be inside my house. Hey, also, if you're in a place that doesn't have air conditioning and you're living through a heat wave, just be careful. I shared a thing out on Twitter that's like, so if you follow me on Twitter, that's cool. If not, my handle's in the description. But it was the signs of heat exhaustion and heat stroke. That's definitely something that's important to keep track of. Also, don't forget to hydrate, and swamp coolers are great. So to get a fan, blow it over like a bucket of ice water, and it'll sit right in front of that, and that'll help. Get rags and dip them in ice water and put them on the back of your neck or your wrists. You can make that water even colder by adding like rubbing alcohol or salt. So that'll drop that temperature. And anyway, it'll help the ice water last longer. It'll also help you feel a little better. Tips and tricks from my childhood. When I was a kid, when I was like a teenager, I would go to Nicaragua every summer for like a medical missions trip. I would help out some doctors that were going down there to provide free medical care. And so we were working outside in lots of heat, and those are without air conditioning and often without power. So those were some good tricks, especially those like neck bands that some of the nice older ladies that went on the trip made that we could cool down with. Anyway, stay safe. Yeah, stay safe because heat absolutely kills, and it's very scary. Okay, sorry. So that was off topic. I'm worried about my friends across the world who don't know how to deal with this kind of heat, or don't live in a place with the infrastructure to deal with this kind of heat. So, anywho, I hope y'all are staying well. So, okay, the video we're going to go over today is this one. Link is in the descriptions. This is Origin, Distant Starlight in a Young Universe. So the problem for young Earth creationists with distant starlight is that if the universe is only 6,000 years old, right, then the furthest away we should be able to see anything is 6,000 light years away, because that light would have taken 6,000 years to get to us. So why is it we can see things, such as with the James Webb Space Telescope, that are much further away than 6,000 light years? We can see things millions and I think even billions of light years away. Right? So that is a problem for a younger creationist. How are they going to reconcile this? If you haven't watched my video where I talk about the one-way speed of the light, that might be a good thing to talk about, because I'm pretty sure that's the point he gets to in this. And so I won't go super deep into the one-way speed of light because I have another video on that, but I'll reference some of the highlights here in this one. Okay, so without further ado, let's start reviewing, shall we? Okay.
Here on Earth, we see light from galaxies billions of light years away.
Sure do.
Based on this, it would seem that creation would be billions of years old.
Sure does.
However, our next guest, Dr. Jason Lisle, presents a compelling argument to the contrary, taking into account the
Well, we'll have to see how compelling we find it, won't we, team? Okay. Oh, my laptop's not plugged in. Let's let him
speed
play
of light
and
and
I'll
the
grab
passage
it.
of time in outer space. The evidence may surprise you. Stay tuned. Coming up next on Origins, Distant Starlight in a Young Universe with Dr. Jason Lisle.
There we go. Boop. I don't want to watch your intro. It's very like 90s-tastic though. Okay.
Hello, my friends, and welcome to Origins. My name is Don Chapman. It's such a privilege to be your host. You know, during our show, we showcase interesting guests who present evidence from science, along with other important facts validating the truth of creation and the accuracy of the Bible.
Okay, so I always like to do this. I like to point out the type of language that they use, that young creationists tend to use, right? So there are outright stating that they're coming into this with a bias, right? So we know that the bias of this show is that they assume that the creation, that the Bible is 100% accurate, and they're going to look for things that validate that assumption, right? So we're coming onto a platform that has a bias, right? And at least they state it right out front. So they're not interested in, say, presenting the most accurate and up-to-date information, right? And they're also not interested in presenting a like complete story or both sides of an argument. They are only interested in validating their specific point of view, that the universe is young, that God created it, the Christian God created the universe in 6 literal 24-hour periods, etc., so forth. Okay, so yeah, sorry, I just like to point out when manipulative language is being used and how they're using that to further like their specific agenda. So, okay, let's keep going.
Today's guest, Dr. Jason Lisle, specializes in astronomy, physics, and apologetics. He has a PhD in astrophysics from the University of Colorado, and he has written books on the subject of astronomy from a creationist perspective.
Okay, so Jason Lisle has some real credentials, and in astrophysics. So that's there's a lot he should know. He should know more about this than I do, right? I have a bachelor's degree in Earth, atmospheric, and planetary sciences, and I did my undergraduate research in planetary science stuff. So that's where like my knowledge comes from. I also have a good understanding of like theoretical physics. Theoretical physics as it applies to nuclear reactors, because I spent 4 years teaching nuclear physics in the Navy, and now I'm doing meteorology. So in terms of the physical sciences, I have a weirdly broad base of knowledge. So anyway, all that to say, Jason Lisle should know more about this than I do. So if I can debunk him, that's not good. I shouldn't be able to do that, right? I shouldn't have the depth of knowledge that he does. So let's keep chatting. Let's keep going into this.
He currently works as Director of Research for the Institute for Creation Research in Dallas, Texas. Dr. Lisle, we are so thrilled you're with us today.
Thanks. Good to be here.
So we're going to talk about distant starlight in a young universe. Help me.
Okay, this is an issue where the critics say, we've got you here, there's no way the Bible can be right because those galaxies are so far away, it proves the universe is billions of years old.
Okay, so I want to point out, no one's saying that. I'm sure some jerk on the internet is saying that, but like, this is not a checkmate Christians kind of thing. This is a, like, if you're going from an unbiased scientific perspective, like this is what we observe, right? What we observe, the observations that we make of the universe do not support the hypothesis of a young universe, right? That would be the way of phrasing it. And I don't like that Dr. Lisle here is framing this conversation as like people who don't believe the Bible is 100% accurate are actively hostile towards Christians, or actively hostile towards people who hold those beliefs, because as I say in almost every Young Earth Creationism video, the majority of Christians accept an old universe, right? And the majority of scientists practice one type of, they practice a faith, right? Most scientists aren't atheists. Anyhow, so there's not a huge antagonistic kind of relationship, no matter what, like r/debate creationism, or r/debate evolution, whichever one, has led you to believe in the actual science. There's not a big antagonistic like relationship here. It's just most scientists don't think about Earth creationism. Anyway.
Okay, so we might as well go home.
Well, yeah, throw the Bible away and just go home. No,
but you've got some answers for us.
There's an answer to this. And let me summarize the problem here, and then we'll go through what I think
Great.
the answer is. Distant galaxies are billions of light years away. Now, a light year is actually a measure of distance, not time. People hear the word year in there, they think it's time.
I hope you guys know that a light year is a measure of distance.
A light year is 6 trillion miles. And so when we say that galaxies are billions of light years away, we mean they're really far away. They're very, very far away. It should take light billions of years to travel that distance, however. Light supposedly it takes 1 year to travel a distance of 1 light year, or 6 trillion miles. And so you'd think it would take light billions of years to get from those galaxies to Earth. Even though light's very, very fast, the galaxies are even further far away than light is fast, as it were. And yet we do see these galaxies. I have pictures of them. We have pictures of them on the screen here. And so the conclusion is, you think, well, billions of years must have elapsed. The light did get here.
Right.
It takes billions of years.
Right.
So the universe has to be at least billions of years old. Therefore, the Bible can't be true. Therefore, we might as well just go home. And
so that sounds like a very logical argument.
It does, but there are some assumptions that.
So, like, again, if you're working from a real science perspective, you just stop at his conclusion, right? Therefore, it looks like the universe is billions of years old, right? Therefore, we have evidence to support that hypothesis, not a young Earth hypothesis. And a scientist isn't going to be like, therefore, throw out your Bible, right? That would be kind of the job of the theologian to come in and like reconcile these disparate things. And honestly, for me, like that, this just means that you can't take the the Bible in English completely literally at every step, right? That's all you got to do. You've got to like understand that the Bible is a collection of different genres of literature, everything from law to like apocalyptic texts that used to be a genre. This is not my field. I don't know all the things. Some of them are letters, some of them are poems, right? So you just have to be a little less rigid in your interpretation of scripture. It's not that hard. It's really not that hard.
Have been made. And that's always the case when people argue against Scripture. Either they haven't read Scripture carefully, or they haven't looked at the evidence carefully, or they've made some assumptions that have affected their conclusions. And in this case, we're going to see there's some assumptions that have been made that, that it's nagging us. And before I talk about what I think the answer is, I want to very briefly hit some things that I think the answer is not. And the reason I do that is otherwise people will call in and say, well, haven't you thought of this? And the answer is yes, we've thought of that. There's a reason why that doesn't work. One solution that people have suggested is that the distances aren't real, that the galaxies, in fact, all of them are really close to our solar system. But that really just doesn't work. Observational science confirms that these galaxies really are at vast distances. I don't want to go into a lot of details of that, but it's not based on evolutionary assumptions. There's good science that confirms these galaxies really are very far away.
So yeah, you can measure how far away an object in space is by using a parallax technique, and very importantly, this doesn't rely on the speed of light. So we know they're really that far away.
Yeah. One idea that's been tried is that the speed of light was greater in the past. And that's a good thing to test, right? That's a good assumption that should be explored. But in fact, I think it's not the case. We have good evidence that the speed of light, in fact, has always been what it is today, the speed of light in vacuum. In fact, the speed of light's tied in with other things in matter. Even the force between protons and electrons is related to the speed of light, interestingly. And so it appears to be a constant of nature that you don't want to tamper with, otherwise matter might not even be possible. Nonetheless, it's good to test these kinds of assumptions, because sometimes evolutionists assume rates are constant when they're not. But in this,
I feel like that's a dig at he's trying to talk about radiometric dating there, when really the thing is that like every time we measure the speed of light, it's constant, and we have no reason to believe that the speed of light hasn't always been constant. And the fact that it is constant is like really weird and has a lot of consequences. And anyway, so there are some things that like could it possibly have been different in the past? I mean, like at the end of the day, that boils down to last Thursdayism, right? Could the universe have popped into existence last Thursday by magic and made to appear as old as it is, right? Like at some point you can't actually disprove that, right? You can't actually disprove that, but the better hypothesis is that the universe did not pop into existence last Thursday, if that makes sense. And so could the speed of light have been different in the past? I mean, like, I guess so. Like, I can't go to the past and prove that to you, but I have no reason to believe it has ever changed, right? There's no good argument that it has changed, just like there's no good argument that the universe popped into existence last Thursday.
In this case, we think that it probably is a pretty good assumption. One that is very common is that maybe God made the beams of light already on their way, or the light in transit idea. And I've got a problem with this, though. This implies that God creates fictional images in movies. Let me explain what I mean by that. In 1987, we saw a star blow itself to bits, and you can see that on the left there is the star, and on the right is the explosion of that star blowing itself to bits. Now, that is in a nearby galaxy. It's 179,000 light years away, which means in secular thinking and conventional thinking, that event actually happened 179,000 years ago, and the light from the explosion finally reached Earth in 1987. Now, of course, some people would say, well, no, God just made the light on its way. But if that's the case, then that means that event never happened. It means that star never existed. It's just a picture in a beam of light that God made about 6,000 light years long. And finally, when it ran out, God made pictures of an explosion, and then it ran out. And today, we look at it, it looks like this little shape that you have there, that hourglass structure. That's the remains of that star. None of that exists if you believe that God created the light already on its way with pictures of these things.
So the light had a cause, and we can't eliminate that.
Yeah, if you believe that God created the light in transit, then the light was not caused by these things. Yeah, and so that's a problem. And in fact, it's not just a problem for that. It would mean 99.9% of the universe is fiction. It's not something that actually exists. It's just beams of light that God created in mid-space, perhaps connected to an object.
That's actually a really good argument against the well, God just made it look like that, right? Because that would have to be God created the light in transit. I'm glad he's doesn't like that, because I've never liked that. I've never liked that argument. But he's doing a really good job of articulating that. So appreciate you, Dr. Lisle. That's good.
Perhaps not.
God can do everything, but I don't think he writes fiction.
That's right. And again, that's my point too. I'm not suggesting that God lacks the power to do that. Of course, he's got the power to do that.
It's the character of God.
Exactly. It goes against his character, against his nature. And some people might say, well, I don't know. I think God might do that. Well, be careful, because how do you know that you're watching us right now on the television? How do you know that I'm here right now if God's creating the beams of light right 1 inch away from your eye?
In touch with reality. Yes.
Exactly. And so I don't think that is a Christian position, a position that's acceptable within the Christian worldview, I should say. a model that I think is a little more likely, a little more plausible, but I don't think it's quite the right answer, is that time dilation has allowed the universe to age millions of years while only 6,000 years has lapsed on Earth. And Dr. Humphreys and a few others have proposed models along these lines. I think that's a great idea to try.
So for anybody who's unfamiliar with time dilation, let's say I have a twin, right? And my twin gets on a spaceship and travels really, really fast, very close to the speed of light, does like a circuit around, I don't know, just travels out for a while and then comes back. And 20 years have passed for me, right? 20 years have passed for me, but my twin gets off the rocket ship and only 1 year has passed for them. So I would then be in my like early 50s and they would still be in their early 30s, right? That's what time dilation is. And it's just that it's one of the consequences of the speed of light being a non-reference frame dependent constant, specifically the speed of light in a vacuum. That weird things tend to happen to things with mass when they get close to the speed of light. So for the traveler, relative to someone not traveling close to the speed of light, to the traveler will, time will slow down, again, relative to me, someone stationary on planet Earth, or a stationary observer. Less time passes for the traveler, length dilation, so they actually get smaller, and mass dilation. Even as they're getting smaller, their mass increases. And these are things that are observed to be true. They're absolutely observed and in fact depended upon in things like supercolliders. So like the Large Hadron Collider, there are certain things that scientists there can only observe because of time dilation and mass dilation effects. Anyhow, okay, so the hypothesis here would be that somehow Earth is traveling faster than the rest of the universe. Yeah. So basically the rest of the universe is stationary and just Earth is moving super fast. That seems real unlikely to me. And here's why. Okay, so you'd have to work it out. One, it couldn't be that only Earth is moving fast, right? Because we're orbiting a sun, right? So you would have to have kind of like, I guess, a gradient of speed that somehow, because the Earth orbits the sun, our solar system orbits the center of the Milky Way. There's a lot of things that are in motion relative to each other that all would have to be adjusted such that the Earth is moving really fast, but for the most part, or locally, the Earth and things nearby are moving really fast, but the rest of the universe isn't. And we know that can't be true for at least as far as like the Voyager 1 probe is, right? Because all of our assumptions about like how communication is going to work as Voyager 1 gets further and further away, those are all true, right? And if it was suddenly like got out of the fast moving thing and was in the slow moving thing, then communication between us and that probe would break down. So this seems highly improbable to me, but let's maybe Dr. Lisle will say, he doesn't seem to like this hypothesis. So let's see what he's got to say.
I don't think it's ultimately the right answer because although it is true that time can flow at different rates in different circumstances, Einstein discovered that, and that's very well-tested physics. The effect tends to be very small, at least in terms of solving the distant starlight problem. It appears to be much too small to actually alleviate that difficulty. And so I don't think that's ultimately the answer. I could be wrong about that. Maybe others are working on it, but I don't think this is ultimately the answer. I think there's a better solution, and the solution that I think involves the one-way speed of light. You see, the speed of light is it's a constant, but that's a round-trip speed. And so let me go up to the board and I'll show you a hypothetical experiment that we could do to measure the speed of light. And so suppose that I'm standing over here and I've got a flashlight and I'm going to measure the speed of light by shining the light down a really long hallway. Let's say the hallway's 186,000 miles long. We'll do it that way to make the math easier. We'll pretend we have government funding. We can waste it that way. And we'll put a mirror at the other end, or maybe I've got a friend at the other end with another flashlight. Either way. And what I'm going to do is when the clock strikes noon, I'm going to turn the flashlight on for just an instant, send that light pulse out. It's going to go out. It's going to bounce off the mirror, come back. And then when I see it, I'm going to look at the clock and record the time. And it turns out that if I were to do this experiment, and that was the length of the hallway, it would take 2 seconds for me to see the reflection. That's how long it takes for light.
1 second down, 1 second back.
Now, we think 1 second down and 1 second back, but maybe that's not the case. And that's the point that I'm going to go into.
All right.
All we know for sure is that it took 2 seconds to make the entire trip. Okay. And so it had to go down 186,000 miles, had to come back. So it had to travel that distance twice, and it took 2 seconds. And so we divide the distance by the time, and that gives us the velocity. And you find, lo and behold, light travels at 186,282 miles per second. And of course, a lot of people think, well, 1 second to go out. I'm glad you mentioned that because that's what most people would assume. And in fact, I illustrated it that way. So I kind of
that's how we did the math, right?
Yeah, I kind of led you to that conclusion. But in fact, this would still work if the speed of light was different going out than it is going back. For example, suppose the speed of light when it goes out is instantaneous. Maybe it takes no time at all to get to the mirror, and then it takes all of the 2 seconds to get back. Okay, now from my point of view over here, I would still see the reflection 2 seconds later.
Right.
The distance is the same. It's got to go out. It's got to come back. 2L, I divide. I get exactly the same speed. Even though, in fact, the speed was instantaneous that way. It was only half the speed on the way back. I get the same answer exactly. Or perhaps, alternatively, maybe it takes all of the 2 seconds to get out to the mirror, and then it travels back instantaneously for whatever reason. The point is, I can't know over here. In any of these circumstances, all I can see is that it takes 2 seconds for me to see the reflection of that light from the moment that I...
Yeah, so this is kind of explaining, he's explaining why, for reals, scientists have never measured the one-way speed of light. And I'm going to let him finish this explanation before I talk about why I don't think that's a big deal, right? And I will again direct you guys to a few weeks ago, I released a video on the one-way speed of light and why I don't think that's like a problem. And also, this is, as I said in that video, I think this is a real fun theoretical physics problem that I suspect one day somebody will solve. I bet one day someone will be able to measure the one-way speed of light, and that person will rightfully so win a Nobel Prize. So it's kind of fun to think about, but also the one-way speed of light versus the two-way speed of light, our ability to measure that doesn't really affect the way we understand our universe to behave. It affects the way we describe it mathematically, but not like, it doesn't affect how we interact with the universe, if that makes sense. Okay.
I've emitted the beam. Again, the distance doesn't change, and the time doesn't change, and so the average velocity doesn't change. In all cases, it's 186,282 miles per second, the speed of light. And I hope you see where I'm going with this, because if it's the case that the speed of light when it's going away from us is slower, but then maybe it's instantaneous when it's back, you'd still get this for the average speed of light, and yet there would be no starlight problem, because the light traveling earthward would be instantaneous. Now, some people have asked, well, why would the speed of light be different in different directions?
You still have a distant starlight problem, and I'm going to let him finish explaining, and then I'll jump into why you still have a distant starlight problem.
I don't really know, but then again, I don't know why it would be the same in all directions either. I mean, we don't really know one way or the other, and a good scientist doesn't say, well, I'd like it to be the same in all directions, and so that's the way it is. Well, we can't, make that assumption.
It's more that we have no reason to believe it's not the same in all directions, if that makes sense.
Just without any kind of evidence. So what we really need to know is, what is the one-way speed of light? What is the speed of light just on one leg of its journey? That's what we'd like to know. Because if it's instantaneous when it's moving toward me, there's no starlight problem. So how would we...
I was going to try to let him finish, but this is really bothering me. Okay, but this is a problem, right? This is a problem. Here's why. Because what we would need is for starlight to behave in the following way. We would need for, light. We would need for light that comes towards Earth to be instantaneous or really fast, right? And light going away from Earth to be the slow, right? So we need to have, this is another argument that like Earth is at the center of the universe, or Earth is somehow special. And so from a creationist perspective, I guess that's not super hard to argue, because you would be like, well, God specifically created Earth for the humans on it, so of course Earth is special. But if you don't start with that assumption, right? If you don't start with the assumption that the Bible is literally true, and anyway, so if we're just going off the observational evidence, then, well, what is so special about Earth? Why does light behave differently coming towards us versus going away from us in particular, right? Why isn't that true of a planet in a different galaxy, or in a different solar system in our own galaxy, right? So there would have to be something physical about the universe that makes Earth special. And we have, and there's no reason to believe that from a purely like a physics standpoint, purely scientific standpoint. So, and then two, there's other things that I don't quite understand. So I understand how assuming that the speed of light, the one-way speed of light equals the two-way speed of light, right? That is an assumption, but it's more of just a, what's the word? Convention. It's more of a convention that makes, again, the math that we use to describe the universe simpler. We could use the convention, so we could use other conventions, and we could mathematically describe the behavior of the universe in the same way. You could assume, for instance, we assume it is the convention that the center of the universe is the point in space where the Big Bang happened, right? And everything sort of moves radially outwards from that. Because honestly, that's kind of, that feels like the most logical way to describe the universe, right? But you don't have to do that. You could assume, you could use the convention that the Earth is the center of the universe, and then just describing the motion of every other object in the universe gets more complicated, but you can do it if you really want to. Um, so, okay, so we know that we could grant Dr. Lisle here the convention that, sure, let's change up all of our math. Let's go with the convention that light that comes towards Earth travels much faster than light going away from Earth. You can even say instantaneously if you want. Okay. So if we're thinking about light that is then traveling from two different stars, okay? One star is 1,000 light years away, and one star is 1,000,000 light years away, okay? For the biblical model, for the young earth creationist idea to be true, then those two stars should appear to be the same age. Why is that? Well, sun, moon, and stars are all created on the fourth day of creation, right? So those two stars should be the same age, right? So if they're the same age, then we should observe them to be the same age, because on that fourth day of creation, they popped into existence because of God, and then their light immediately traveled to Earth, right? So we should see two stars that are the same age. But that's not what we see, right? That's not what we actively observe. We observe objects further away from Earth in space. The farther away they are in general, the younger they appear. This is because we're literally looking back in time. We're looking at, if something is 1,000,000 light years away, under our conventional understanding, right, we're looking at something as it was 10 million years ago. So anywho, so in order to get that light being instantaneous and account for what we actively observe, right, what we would need is, so I see something that's farther away that is old, right? Excuse me, the farther away it is, the younger it appears. Okay, so I somehow have to have so it emits, that object that's far away emits light and gets to where Earth was when it emitted that light. Let's go with instantaneously. So in order for that object to appear young, we need the Earth to have moved, right? And so these are all things that you have to account for if you were going to mathematically describe, right, the universe. So if you're going to describe what you can use the convention that the speed of light, that light travels instantaneously towards the Earth and slow away from the Earth. You can make that assumption if you want. You can use that convention if you want, but you still have to account for the things we actively see, right? Such as faraway objects looking young. And there's, anyway, so it doesn't just say that the one-way, we could just assume if we just use that change our assumptions of the one-way speed of light to this, then creationism has no problems. So that's not actually true, right? Because you change that convention and then you have to deal with the fallout of changing that convention. Okay, so let's see if he addresses any of that.
Go about measuring the one-way speed of light. We can't use a mirror anymore because we just want to do a one-way trip. So we're going to have a detector over here.
I'm going to skip through
and
some
we're going to
of
need another
this.
clock arrives. Okay, and so I'm going to receive. We'll have a long haul math and say the light went over, hit the phone. The phone read 12:05, and I said, light takes 5 minutes to travel from my watch.
Okay.
My watch. And so
we're still
what
talking about
happens is the radio transmitter at, let's say, midnight sends out the radio pulse, and then my watch sets it to.
If you guys want to see his full argument about how measuring the one-way speed of light is currently impossible, like I said, the link to this video is in the description. You're free to do that, but I've covered that in a previous video, so I want to get back to his arguments about I want to see if he addresses the fallout of that assumption, right? Synchronicity versus asynchronous convention. Yeah, it's a matter of convention. That is true. Okay.
The other side of the break.
Right, we got to take a break, but you've got a solution, so don't you go away. We'll be right back.
Okay. Did this used to be on TV?
It's in a dilemma.
Yes.
Would you restate the dilemma and then, for heaven's sake, solve it for us?
Yes, we've been trying to answer this question of what is the speed of light in one direction. We know it's round trip speed. That's easy. But how do you determine its speed in one direction? And what we found is, in order to measure the one-way speed of light, you'd have to have two clocks that are exactly synchronized. But it turns out, in order to have two clocks that are exactly synchronized by distance, you'd have to already know the one-way speed of light. But you can't measure the one-way speed of light unless you have synchronized clocks, and you can't synchronize your clocks unless you already have the one-way speed of light. And so we're stuck in a permanent catch-22.
Yeah, this is like the paradox. This is why we haven't measured the one-way speed of light as of the year of our Lord, 2022.
Now, I'm going to suggest that it's not so much that there's a solution to this. There's an answer. It's not an answer that perhaps people would like, but I'm going to suggest that the one-way speed of light is a matter of convention.
That's true.
And the convention is something that
that's not something that like physicists don't know. You know what I mean? Like, yeah.
We all human beings, we agree to it, and it works as a result of that. As long as we stick to it, everything works. Like the number of inches in a foot. Now, I don't know historically why there are 12 inches in a foot, but somebody decided there should be 12 inches in a foot, and we all agree to that, so it works. As long as we stick to that, it's fine. Driving on the right side of the road is convention. We all agree to it, and it works. You don't agree to that, you got problems, right? Yes. But on the other hand, if you go to a different culture, you go to Australia, everybody drives on the left side of the road, and they agree to that, and that works.
That's
exactly.
Right.
And so I'm going to suggest the one-way speed of light is like that, because it's not something that you can measure without already knowing it. That suggests it's kind of like inches in a foot. It's not something the universe determines, or something that God has determined. It's something that he leaves up to us, interestingly. And so it turns out you can actually define the speed of light, the one-way speed of light, to be basically whatever you want it to be within certain constraints. And that will tell you then how to synchronize clocks. And then when you go to measure the one-way speed of light using your now synchronized clocks, it will be whatever you chose it to be. So it's a convention, interestingly. And this principle is called the conventionality of distant simultaneity, or sometimes just the conventionality thesis. And if folks want to look that up on the internet, that's what.
So everything he's saying here is true. This is just a convention. Like we assume we use the right-hand rule, so X, Y, Z we use a right-handed coordinate system, not a left-handed coordinate system. 0 Kelvin is defined as absolute zero, right? But like Celsius is arbitrarily defined such that 0 C is the freezing point of water at 1 atmosphere, and 100 C is its boiling point, right? Those things are that's all convention. We tend to use conventions that kind of make our life a little easier, because why would we intentionally choose something that makes our life harder, right? And that's what it is. If we chose a different convention, does the universe stop behaving? Do we change how the universe behaves? No. Okay.
They want to research. And this is actually a pretty well-established principle in physics. Now, not 100% of physicists agree with it, but most of us do. Most of us who are trained in relativity. The fact that the one-way speed of light is not measurable, and in fact, is something that we human beings get to choose. And what that means is, since I can choose the one-way speed of light within certain constraints, then I can then have a synchrony convention. Now I can synchronize my clocks, but it's a bit circular.
To the conventional standard, yeah.
Exactly. And it doesn't mean that the other conventions are wrong. They're just different. It doesn't mean that driving on the left side of the road is wrong in Australia. It's just a convention that they use. Whatever convention you choose, if you're consistent, any experiment you do will verify your choice. And so what most physicists do then is they'll choose the speed of light to be the same in all directions because it makes the math easier. But that's the only reason. It makes the math easier. You don't have to make that choice. In fact, let's suppose. But
again, making a different choice doesn't change anything fundamental about the universe, right? So, choosing a different convention doesn't change the fact that when we point our telescopes up at space, we're seeing things as they were in the past, not as they are now, right? And that brings in a problem. That's the root of the distant starlight problem for young Earth creationists, is that not just, well, how is it that I can see something that is a billion light years away, but also, why does that object that's a billion light years away look younger than something that's a million light years away? That's the root of the problem, right? And so I feel like there's a lot of obfuscation going on here. But anyway, let's let him keep talking.
You had 2 bolts of lightning that strike at the same time, or they're expected to strike at the same time. And that's the prediction. And you want to say, I wonder if they really are going to strike at the same time. What I'm going to do is I'm going to go stand directly between the 2 lightning bolts, okay? And they're separated by a distance. And I've got mirrors here so I can see both directions simultaneously, right? And if they strike at the same time, the light will come to me. And if they strike at the same time, I'll see them at the same time because I'm exactly in the middle. But that, of course, assumes that the speed of light is the same in all directions. Now, of course, I'm allowed to stipulate that. I'm allowed to choose that as a convention. And so he says here, if only I knew that the light by means of which the observer at M perceives the lightning flashes travels along the length A to M with the same velocity as along the length B to M. If only I knew that the speed of light is the same in all directions. But an examination would only be possible if we already had at our disposal the means of measuring time, if we already had synchronized clocks, which we can't do fundamentally. It would thus appear as though we are moving in a logical circle. That's that catch-22 we've been talking about. That light requires the same time to traverse the path A to M as the path B to M is in reality neither a supposition nor a hypothesis about the physical nature of light, but a stipulation which I can make of my own free will in order to arrive at a definition of simultaneity. What he's saying is, I can choose the one-way speed of light to be the same in all directions if I so wish to do so, and that will tell me how to determine synchronized clocks. That's my choice. But if somebody else wants to make a different choice, they can do that too. It's something we stipulate of our own free will. And that is a quote by Albert Einstein.
Yeah.
Oh, wow.
Yeah, this is all true. Sorry, I don't know. He's talking about this like this is some like big revelation, right? Or like really big thing. But I mean, all of this is available on like Wikipedia. No, granted, I don't know when this was filmed, so maybe it wasn't then, but okay. But none of this solves the distant starlight problem, is my point. I would like him to get to distant starlight.
Yeah, Einstein realized that the one-way speed of light is not a property of nature. It's something we get to choose. And that
He
tells us how to
wrestled with the same
synchronize.
thing, yeah.
Exactly, yeah. He writes about that in Relativity, his premier book on relativity. And so what this means is there's more than one way to synchronize clocks, and therefore the speed of light in one direction can be different depending on which synchrony convention you choose. Most physicists choose what Einstein did, the Einstein synchrony convention. They choose the one-way speed of light to be the same in all directions because it makes the math easier. And in that convention, light does take billions of years to travel billions of light years. But I want to suggest to you that there's another convention that we could use, the anisotropic synchrony convention. Anisotropic means different in different directions. And under this convention, the speed of light when it's moving directly toward you has infinite speed. Okay, it takes no time at all for light to get toward you because that's how we're choosing to synchronize.
Okay, there's a bit of a problem here. Okay, there is a bit of a problem here. So one, I love this. There is no distant starlight problem if the Bible uses the asynchrony convention. Okay, because what he's defining, what would have to be true, because like no matter which direction we point our telescope, the universe seems to we still see things really far away, right? There's no like, oh hey, if we point in this direction, we only see things close together, versus if we point in this direction. So no matter what direction we point our telescope, everything looks really far away. Cool. So that would mean the speed of light traveling not towards an observer, but the speed of light as it travels, like to the speed of light. The assumption we would need to make is that, okay, sorry, the one-way speed of light is infinite when directly toward an observer, but 1/2 c when moving directly away. Okay, the way that's phrased implies that I matter, right? So when the speed of light is coming towards me, it's instantaneous. And if I teleported onto Pluto, right, I'm really far away from where I used to be, but now the speed of light is directed, like the speed of light, now the speed of light is instantaneous as I observe it on Pluto. So how does the light know that I moved, right? So that's a problem. So this is worded really, the way this is worded, this can't be true. Because it would also mean that, okay, so I'm on Pluto and you're on Earth, and the speed of light is instantaneous towards both of us, right? Because we're both observers. But what would happen if, like, I shot a laser at you, right, and you shot a laser at me at the same time? Well, would that light get to both of us instantaneously? That's not what we observe, right? That's certainly not what's observed. Because so this phrasing here is bad. And I don't know if he tried to like simplify it down for a non-specialist audience, but the phrasing here is really bad. I assumed this would be like relative to a fixed point in space, or relative to a fixed point in space-time. Like somehow we don't need to worry about how the speed of light is instantaneous as it's directed towards the center of the Earth, right? Sort of towards the Earth's center of mass. Like that's what we're defining. But then light would reach me and someone, say in Australia, would reach us at different times, because like that distance traveled would be different. I don't know if you could actually measure that from starlight. So I feel like this is a really bad convention that's going to make your life really difficult, and is also going to, like, again, it doesn't solve the distant starlight problem because like when we look to old light, we see a young universe. And if all light travels instantaneously towards me, the observer here on planet Earth, that shouldn't be true. Okay.
Nice clocks. Okay, so when the light passes by this clock, it's noon. When it passes by that clock, it's noon. When it reaches you, it's noon. Therefore, it takes no time at all for the light to travel that distance. And I want to suggest to you that, well, of course, if that's the case, if we define time that way, then we're looking at the universe in real time. Because the light, as soon as it's emitted from the star, it reaches your eye, taking no time at all to get from there to here. And that's an anisotropic synchrony convention. Now, if you were to shoot light back out, it would take a long time to get back because we know the round trip speed of light, that's something that's set by God. That's 186,000 miles per second. You can't change that. But the one-way speed we get to define. And I want to suggest to you that this anisotropic synchrony convention is, in fact, the one that is used in Scripture because, first of all, it was the one that all ancient cultures implicitly used. They did not subtract off light travel time. When you see something happen, that's when it happens, in terms of their understanding.
Okay, my guy, that's not a good, like, that's not a good assumption. Um, because ancient peoples understood like we have made advances in science, right? We've made advances in math, right? Just because, so like, what is it? The ancient Babylonians got really, really close. They defined a number very close to pi, but they didn't have, by using ancient Babylonian math is very cool. They're one of the few cultures that independently developed a zero, and they have like trigonometry before they have a zero, which kind of blows my mind, but it's really cool. So they by like dividing up a circle in their like base 60 math system, they defined a number very close to pi. They saw that relationship, but they didn't have a concept of irrational numbers. So should we use their understanding of pi just because it was mathematically advanced for the time, or should we use what we know pi to be, which is an irrational number? Obviously, we should use the advancement. So just because ancient peoples didn't have an understanding of the speed of light being a like non-reference or independent constant, like the ancient peoples didn't understand relativity. We didn't understand relativity 100 years ago, right? Relativity is a new thing, and it's weird, and it has weird consequences, and that's really cool, right? But then that's a huge advancement. So like we should base our knowledge of the universe off of the best available information. So that's silly. He also still hasn't explained my one question, my main question here, which is then why the difference in apparent age, right? Which is perfectly explained if the light takes a long time to get to us, right? And notice that changing a convention doesn't physically change how the universe behaves, right? He is suggesting a change in how the universe behaves by a change of convention. And that's not supposed to work. That's not how any of this works.
Of space and time. And of course, I also want to suggest to you that the Bible is using this anisotropic synchrony convention, partly because, again, it's the version.
Or Genesis 1 is a poem.
That all ancient cultures would use, but also because of the way Genesis is worded. If you take a look at Genesis 1, 14 and 15, God here is describing the creation of the sun, moon, and stars, also the lights in the heavens. Then God said, let there be lights in the expanse of the heavens to separate the day from the night, and let them be for signs and for seasons and for days and years. And he goes on to say, and let them be for lights in the expanse of the heavens to give light on the earth. And it was so. What was so? Well, God made the lights, and they gave light on the earth. Apparently, the very instant that God created the stars, they immediately began giving light on the earth. Their light reached the earth instantaneously.
Then why can we observe stars forming today if every star was made on day 4 of creation?
And that suggests the Bible is using this anisotropic synchrony convention, because under that convention, which is perfectly compatible with all physics that we know about, light takes no time at all to travel from those distant galaxies to Earth. It can reach the Earth just like that. So what that means is the universe is not billions of years old just because the galaxies are billions of light years away, because the Bible's using.
That's a big jump, right? There's like 12 steps in between statement A and statement B. And again, he hasn't addressed any of the concerns that I brought up, right? If all stars were created on day 4 and their light then instantly got to Earth, why can we see stars being born today? Why do stellar nurseries exist today? Why does old light show young features, right? He hasn't explained any of that.
This anisotropic synchrony convention in which we see the universe in real time. Light from those galaxies reaches Earth instantaneously under that convention. It doesn't mean the secular convention is wrong. It's just different, and it's not the one that the Bible uses. So my point is, the secularists really can't say, well, we know that light takes billions of years to get from there to here, therefore the Bible's wrong, because the Bible's using an anisotropic synchrony convention, in which case it takes light no time at all.
But you still have to explain these other things, right? Your convention still has to work with how the universe behaves, and changing a convention doesn't change anything fundamental about the universe. So again, it's not as simple as this asynchronous thing, right? And so you would have to explain, I guess you could arbitrarily like it's not as he's overly simplifying this, right? Like, okay, so we're going to choose instead of light being speed of light being homogeneous, right, the same in all directions, we're going to assume it is heterogeneous, different in different directions. So you would need to define how it's different, right? And he's just saying like light can get to Earth instantaneously. Okay, cool, but Earth is moving, right? So how does that bring it into it? Light is still red shifted. If to get to us instantaneously, that means it didn't travel at all the points in between, right? If it's getting to us instantaneously, then I guess it has to be like infinite speed, but like then how is that light red shifted? Again, why does the farther away something is from Earth, in general, the younger it appears? Your convention still has to explain all of those things. So he's not addressing any of the problems
to get from those galaxies to Earth.
Huh.
Yeah.
That's amazing. So is this what you believe happened? Do you believe it? You believe your convention is that?
I think this is the right answer
This
because
is the answer.
I'm convinced by verses like Genesis 1:14 and 1:15 that that the stars did immediately fulfill their God-ordained role to give light upon the earth. He spoke and they stood fast,
Yes.
and they immediately fulfilled their God-ordained role of
They-
giving light upon the earth.
They obeyed him in
Yeah,
an instant. Yeah.
exactly. And that is the convention that all ancient cultures would have used.
My dog really wants to go outside.
The Bible meaning to be understood by many
Just a
different cultures,
minute.
not just modern physicists. I think that's the convention God would use. And the neat thing about this is this is known physics. This isn't some crazy creationist coming up with these new ideas. Albert Einstein come back, and then when I see
Oh
it,
no,
I'm
what
going to
did
look
it
at the
do?
clock and record the time. Yeah,
That's amazing. So is this what you
answer because stars did immediately fulfill their God convention that
You
all
guys are
ancient
gonna walk
cultures
with me
would
while I
use. The
let
Bible
Sweet
meaning to
Shep
be understood
outside.
it by many different cultures, not just modern physicists. I think that's the convention God would use. And the neat thing about this is this is known physics. This isn't some crazy creationist
see him?
coming up with these new ideas. Albert Einstein realized this, and secular physicists would realize that indeed the one-way speed of light is conventional, and therefore there really is no distant starlight problem. There never has been, ironically.
That's absolutely astounding. So we've been intimidated by a problem that doesn't exist.
Again, address all of the concerns I've brought up that I, a non-astrophysicist, came up with off the top of my head. Thus, Shep being very big and brave. If
Yeah,
you heard
and of course,
Mark.
I've written about this, and people can check out our website, ICR, and
Okay.
okay,
They're plugging stuff. Okay, team. So that is. This is why we don't normally film from inside, because the very good boys are very needy. That's Dr. Lisle's distant starlight problem. I'm unconvinced. I think he accurately described the fun physics conundrum, fun physics problem of the one-way speed of light, but didn't actually connect all. Just kind of jumped from it's a convention that the speed of light is homogeneous, is the same in all directions. That doesn't have to be the convention. Light could get to Earth instantaneously. Oh my gosh, I'm trying to fix my hair and I'm just making it worse. Okay. Therefore, no distant starlight problem. But there's still a problem, right? If you there's still all the things that I mentioned. So let me. How does redshift work? Why is Earth special? And is it a specific point on Earth? Does that move as Earth moves? Right? Is it, if I were to go away from Earth, would I observe the universe to be different? You know what I mean? If all stars are created on day 4 of creation, why do some appear younger and older than others? Why can we observe stellar nurseries where stars are actively forming? Why does old light show young features? So he doesn't address anything else. It's just kind of a surface level answer. And that is, I was chatting with a friend of the channel, Dapper Dinosaur, the other day, and we were talking a little bit about how often in evangelicalism, you get a lot of simple answers to complex questions, right? And often it boils down to, "For the Bible told me so," right? To think an apology as a little jingle. That's obviously from a Christian children's song, if you didn't grow up going to VBS. Anyway, yeah, so it's almost like a thought-stopping technique. And so the purpose of videos like this is, if someone asks a young Earth creationist, well, what about distant starlight? They can just say, oh, the one-way speed of light is instantaneous, right? They have a short answer that on the surface level addresses the question, but doesn't hold up to deeper digging. And science is all about that deeper digging. Anyway, okay, this video is getting long. It's now over an hour, so I'm going to go ahead and sign off. I hope you guys are great. Like, subscribe, YouTuber stuff. If you are willing and able to financially support my channel, you can leave a super thanks below or see the link to my Buy Me a Coffee fund in the description. Have a great day. Bye, team.